Hi everybody, this is Mark. I want to give a quick video introduction to GC-SOS gas chromatography simulation and optimization software. Okay, so when you first start the program, you're presented with really two options. One is create a new file. So this is where you would enter your existing separation into the program as a training run to enable simulation and optimization. Or two, open an existing file. I'm going to go ahead for today's demo and open an existing file. This is one of the many example files that are included with the program installation. The program presents a pretty standard Windows interface. At the top is a menu line where various choices are accessed. Below that is a standard toolbar. The central part of the program is the main display window. Currently I'm showing a chromatogram. You can also display text in a table format if you choose. And below that are the tab area where various run conditions are entered, as well as some existing features which I'll demonstrate. Okay, so this particular separation could represent your existing separation that you're currently running today. As you can see, the existing separation has an initial temperature of 62 degrees where it's held for 12.5 minutes. It then ramps at 3 degrees a minute to 92 degrees, and then at 5 degrees a minute for 200. The initial pressure is 10 psi, and the initial column is the 30 by 0.25 by 0.25. Okay, this separation is actually not a bad separation. We have a pretty good minimum resolution of 1.0, and the runtime is 38.3 minutes. What you might want to do is to try to either decrease the runtime or increase the resolution. And one way to do this is to just go ahead and manually enter in the conditions and then execute a new simulation. You would use your expert knowledge and do this iteratively to try to affect the separation in a positive way. And you can see in the resulting chromatogram, I've been able to decrease the runtime. I did decrease also, unfortunately, the minimum resolution. And you could go back and forth and try to tweak this. And this is really one of the benefits of simulation, is that you can execute these new run conditions very quickly, much faster than it would take on an actual chromatographic run. Okay, one of the good features of this program, GC-SOS, is the auto optimization capability, which I want to demonstrate. This is a numerical routine that automatically finds the best run conditions for your separation given your input parameters. So the first parameter input is the minimum resolution desired. So this is basically the minimum you want between all peaks. Next is the temperature ramp rate. Generally, you want to enter in the maximum that your oven can sustain. And on the right is the pressure conditions. So you can enter constant pressure, or if you have programming, you can enter in a constant velocity or constant flow. Okay, my initial separation featured a minimum resolution of 1.0, which is okay. What I want to try to do is to try to optimize this run, maintain the same minimum resolution, but try to decrease the runtime a little bit. So again, my training run was about 38 minutes. So let's just go ahead and execute an optimization. And these optimization results have come back with a run with our minimum resolution that we asked for. It did decrease the runtime substantially, but recall before we were about 38 minutes, now we're down to about 16. And we do have our minimum resolution maintained. So the optimization was able to decrease the runtime significantly. You might also, if you have programming, you can usually use this to some advantage. It will generally give you a few percentage points of efficiency on top of the isobaric. So let's just try this real quick. So I was able to, cut off a couple of minutes from the runtime using the pressure programming. Another thing you may want to do is actually increase the resolution a little bit. So here I've increased the resolution to 1.5 and I'm down to 25 minutes. If you're okay with your initial runtime of 38 minutes, you can just increase the resolution and still maintain the same runtime. So here in about 35 minutes, I was able to increase the resolution to 2, maybe even get a little bit more out of it, still maintaining the 38-minute resolution or runtime that I started with. Okay, so this is basically the same amount of time, but considerably more resolution than I started with. So this is a pretty good compromise. It's actually increased the resolution and also decreased the runtime to about 25 minutes. At any time you can click on the chromatogram and the analysis tab is activated where the cursor is actually followed in real time, showing you the current temperature, pressure, and also the resolution between adjacent peaks of the cursor. The final feature I want to demonstrate today is the animation tab. This is a schematic instrument that basically shows you the migration of your peaks during the run. You have a symbolic injector, symbolic column, and a symbolic detector. There's a symbolic injector that shows you the chromatogram. The display is updated kind of in real time, and you see your peaks migrating from the injector towards the detector. You can also see the effect of band broadening as these peaks migrate down the column. They become wider. This is a great tool for teaching GC retention principles and optimization principles as well. Okay, so today I've shown you how to execute a basic simulation, also how to execute the auto optimization capability. You've come up with a run now that is actually an improvement over your existing run. Recall the existing run was about 38 minutes with a minimum resolution of 1. We were able to come up with a resolution of 1.5 and decrease the runtime down to about 25 minutes. So you could actually enter these new run conditions into your instrument and go ahead and run the optimized run. If you wanted to, you could actually take that result, the actual results that you get, and enter that back into the program as a second training run for increased accuracy if you wanted to. So that's a quick introduction. We encourage you to visit www.gcsos.com for more information or to download a demo. Thank you.